Hello there and welcome to the Dreamy Science channel. I'm so glad you found your way here tonight. Maybe the day has been long and steep, or perhaps you're the kind of person who finds peace in thinking about ancient stone giants that have watched over Earth for millions of years. Either way, tonight's journey is crafted for you. You have nothing to do now but breathe slowly, let your muscles soften, and allow your thoughts to drift like morning mist through quiet valleys. Because tonight, we're exploring the most soothing truths about mountains. Those silent sentinels that rise from our planet's surface in gentle majesty. We'll wander through facts about their formation, their hidden ecosystems, and the quiet ways they shape weather, water, and time itself. Some discoveries may surprise you with their elegance. Others might simply float past like clouds around a distant peak, soft and unhurried. And if these peaceful explorations help you unwind or offer a calm way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now let's begin our gentle ascent into the world of mountains. Mountains grow so slowly, you could never see it happen. In the quiet persistence of geological time, mountains rise at rates measured not in minutes or hours, but in millimeters per year. The Himalayas, those towering giants of Asia, climb skyward at roughly the same pace your fingernails grow. That's about 4 millimeters annually, a movement so gradual it's invisible to human perception. Over millions of years, these tiny increments accumulate into peaks that scrape the belly of clouds. It's a reminder that the most profound changes often happen in whispers, not shouts. The mountains around you today began their slow dance toward the sky long before humans walked the earth, and they'll continue their patient rise long after we're gone. Every mountain range tells a story written in stone. The rocks that form mountain peaks are like pages in an ancient book, each layer recording a different chapter of Earth's history. Some mountains began as ocean floors, their limestone peaks containing fossilized sea creatures that lived hundreds of millions of years ago. Others were born from volcanic fire, their dark basalt telling tales of molten beginnings. The Appalachians hold rocks that are nearly 500 million years old, while the younger Rockies still wear the sharp edges of their relatively recent birth. When you look at a mountain, you're seeing time made solid, stories of ancient seas, wandering continents, and the slow ballet of tectonic plates, written in layers of sediment and stone. Mountains create their own weather patterns in gentle whispers. As air masses encounter mountain slopes, they're forced upward into cooler regions of the atmosphere. This lifting causes moisture to condense and fall as rain or snow on the windward side, while the leeward side often remains dry in what's called a rain shadow. Mountains don't just experience weather, they sculpt it with quiet authority. They can split storm systems, create their own clouds, and even generate their own winds. The thermal currents that rise from sun-warmed slopes can lift eagles and hawks in effortless spirals, while cool air flowing down mountainsides at night brings the crisp freshness that mountain dwellers know so well. Snow on mountain peaks can take decades to become rivers in valleys below. High in the mountains, snowflakes that fell during your grandmother's childhood might still be making their slow journey toward the sea. In vast snowfields and glaciers, layers of snow compress into ice, that moves at the pace of patience itself. This frozen water storage system feeds rivers throughout the year, releasing its treasure gradually as temperatures warm. A single snowflake that lands on a high peak might spend 20, 50, or even 100 years as part of the mountain's icy crown before finally melting and beginning its journey to the ocean. Mountains are the planet's water towers, holding winter's gift in cold storage until life below needs it most. Ancient mountains wear smooth shoulders from eons of gentle erosion. The Appalachian Mountains of eastern North America were once as tall and jagged as today's Himalayas, but time has been their patient sculptor. Wind, water, and ice have worked for hundreds of millions of years to soften their profiles, wearing away sharp edges and creating the rolling, forested peaks we see today. These elder mountains have a different kind of beauty than their younger, more dramatic cousins. Their slopes are gentler, their summits more rounded, like old wise faces marked by experience. They remind us that even the mightiest peaks eventually learn the art of graceful aging. Some mountain lakes have been isolated for millions of years. High in mountain ranges around the world, there are lakes that have existed in solitude for so long, they've become living laboratories of evolution. Lake Baikal in Siberia, though technically in a mountain valley, contains species found nowhere else on Earth because it has been isolated for over 20 million years. Similarly, many smaller alpine lakes contain unique microorganisms and sometimes fish species that evolved in complete isolation. These mountain lakes are like biological islands in the sky, quiet worlds where life has taken its own unique path, undisturbed by the changes happening in the valleys far below. Mountains influence the shape of clouds in ways that seem almost magical. As air flows over mountain ranges, it creates standing waves in the atmosphere that can extend for hundreds of miles downwind. These invisible waves sometimes become visible when moisture condenses at their peaks, forming long, smooth clouds that appear to hover motionless in the sky. Lenticular clouds, as they're called, often look like flying saucers or cosmic visitors, but they're simply the atmosphere's way of marking the presence of mountains, even when the peaks themselves are hidden. These clouds can maintain their shape for hours, gentle reminders of the mountain's influence on the sky above. The oldest rocks on Earth's surface are found on mountain peaks, while valleys fill with sediment and ocean floors are constantly recycled. Mountain peaks can preserve ancient rocks for billions of years. Some of the oldest rocks ever discovered, dating back over 4 billion years, are found in the Canadian Shield and similar ancient mountain regions. These rocks formed when Earth was still young, when the atmosphere contained no oxygen and life existed only as simple microorganisms. Touching these ancient stones is like reaching across deep time, connecting with a planet that was utterly different from the one we know today. Mountains are Earth's memory keepers, holding fragments of the earliest chapters in our planet's long story. Treeline creates natural galleries of botanical art. On mountains around the world, there's an invisible boundary where trees can no longer survive the harsh conditions of high altitude. This tree line creates some of nature's most stunning displays, where hardy trees twisted by wind and weather form living sculptures against the sky. These Krummholz, or crooked wood trees, grow in fantastical shapes, their branches flowing like frozen rivers or reaching toward the sky in graceful curves. Above the tree line, alpine meadows burst with tiny wildflowers during brief summer seasons, creating carpets of color that seem all the more precious for their fleeting nature and remote locations. Mountains grow crystals in hidden chambers deep within their hearts. In the quiet darkness of mountain interiors, geological processes create crystal caverns of breathtaking beauty. As mineral-rich water seeps through cracks and fissures, it slowly deposits layers of quartz, calcite, and other minerals over thousands of years. These hidden chambers, sometimes discovered by miners or revealed by erosion, contain crystals that grew in perfect silence and darkness, some reaching enormous sizes. The mountains hold these secret galleries like buried treasures, rooms of glittering beauty that few human eyes will ever see, growing slowly in the patient darkness of geological time. Alpine glaciers move like rivers of ice in slow motion. High on mountain slopes, glaciers flow downward at speeds measured in inches per day or feet per year. These rivers of ice carve valleys, transport boulders, and sculpt the landscape with patient persistence. The ice at the bottom of a glacier can be hundreds or even thousands of years old, while new snow continues to be added at the top. Glaciers are like frozen time machines, preserving bubbles of ancient atmosphere and particles of dust from centuries past. As they move, they create their own weather patterns, cooling the air around them and sometimes generating their own winds. Mountain echoes can travel for miles through valleys. The acoustic properties of mountain valleys create some of nature's most haunting sound effects. A shout from one peak can bounce off canyon walls and travel for miles, arriving at distant locations as a ghostly whisper. Some mountain ranges are famous for their echoes, where a single call can return as multiple overlapping voices, each arriving at a slightly different time as the sound bounces off various cliff faces and rocky outcrops. These natural amphitheaters have inspired musicians and storytellers for millennia, places where the mountains themselves seem to sing back to those who call out to them. Certain mountains create their own magnetic fields. Some mountain ranges contain large deposits of magnetite and other magnetic minerals that can actually deflect compass needles. These magnetic anomalies were often noted by early explorers and sometimes attributed to supernatural causes. The magnetic fields created by these iron-rich mountains can affect navigation equipment and create localized variations in Earth's magnetic field. Birds and other animals that use magnetic navigation sometimes show unusual flight patterns around these peaks, as if the mountains themselves are whispering different directions to their internal compasses. High altitude changes how your body works in fascinating ways. As you climb higher into mountain environments, your body begins a remarkable series of adaptations. Your heart rate increases to pump blood more efficiently through thinner air. Your breathing deepens and becomes more frequent. Over days and weeks at altitude, your body produces more red blood cells to carry the precious oxygen more effectively. People who live their entire lives in high mountain regions develop enlarged lungs and hearts, and their blood chemistry adapts to function optimally in the thin air. These adaptations happen quietly and automatically, your body's way of learning to thrive in the rarefied atmosphere of high places. Some mountain peaks pierce through cloud layers into perpetual clarity. Above a certain altitude, mountains rise into air so thin and clear that clouds rarely form. These high peaks exist in a realm of constant blue sky, where the air is so pure it seems to sparkle. The view from these heights reveals the curvature of Earth itself, and the sky takes on a deeper blue that gradually fades toward black at the edges of space. Climbers who reach these extraordinary heights often describe a profound sense of peace and clarity, as if they've entered a different world where earthly concerns fade away like the clouds far below. Mountain streams carry the songs of snowmelt and rain from peak to valley. Every mountain stream begins as a whisper, perhaps a single drop of melted snow or a trickle from a hidden spring. As it flows downward, it gathers companions, other drops and trickles joining its journey toward the sea. The sound of mountain water has a particular quality, clear and musical, shaped by the rocky beds and boulder-strewn channels it follows. These streams carry more than water. They transport dissolved minerals that will nourish plants and animals downstream, tiny particles of the mountain itself traveling toward distant oceans. Ancient peoples saw mountains as bridges between earth and heaven. Throughout human history, mountains have held special significance in cultures around the world. Many were considered sacred, dwelling places of gods or spirits, or pathways to other realms. The ancient Greeks believed Mount Olympus was home to their gods. Indigenous peoples of the Americas often viewed certain peaks as sacred ancestors or spiritual guardians. This reverence for mountains appears in nearly every culture that has lived near them, perhaps because their heights naturally draw the eye and imagination skyward, making them seem like natural links between the earthly and the divine. Mountains create their own seasons at different altitudes. On a single mountain, you can experience multiple seasons simply by changing elevation. Spring flowers might be blooming in valley meadows, while winter snow still blankets the peaks above. This vertical zonation creates distinct ecological layers, each with its own climate, plants, and animals. A journey up a mountain is like traveling from one latitude to another, with different life zones succeeding each other as you climb. Desert plants might grow at the base, giving way to grasslands, then forests, then alpine tundra, and finally bare rock and ice, all within a few thousand feet of vertical distance. The silence of high mountains has a quality unlike anywhere else on Earth. Above the tree line, in the thin air of high peaks, sound behaves differently. There are fewer molecules to carry noise, and the clarity of the atmosphere seems to sharpen what sounds do exist. The silence isn't empty. It's full of subtle presence. The whisper of wind across stone, the distant crack of ice, the soft patter of your own heartbeat. This mountain silence has drawn contemplatives and mystics for centuries, a natural cathedral where the absence of noise becomes its own profound presence. In these high places, even silence seems to breathe. Mountain roots extend deeper underground than their peaks reach into the sky. Beneath every mountain range lies a hidden mirror image, roots of rock that plunge deep into Earth's crust. These geological foundations can extend 20 or 30 miles down, anchoring the visible peaks like icebergs floating in reverse. The continental crust thickens beneath mountains, creating a buoyant foundation that keeps them afloat on the denser mantle below. It's a quiet balance. Mountains floating on stone seas we'll never see. Their invisible foundations reaching toward Earth's molten heart, while their peaks stretch toward distant stars. Some mountains are slowly sinking back into the earth. Not all mountains are growing. Some ancient ranges are gradually subsiding, their weight causing them to settle deeper into the crust over millions of years. The Scandinavian mountains, freed from the immense weight of Ice Age glaciers, are still slowly rebounding upward, while other ranges compress under their own mass. This gentle settling happens so slowly, it's measured in fractions of millimeters per year, a geological breathing where mountains rise and fall like slow waves in an ocean of stone. Mountain shadows create microclimates that can differ by decades of seasons. The north faces of mountains in the northern hemisphere receive less direct sunlight, creating pockets of perpetual coolness where snow lingers long after valley floors have warmed into summer. These shadowed slopes can harbor plant communities that belong to completely different climatic zones, relics of ice ages preserved in permanent twilight. A single mountain can contain both sun-baked southern exposures blooming with desert flowers and cool northern faces where Arctic plants thrive just hundreds of feet away. Volcanic mountains build themselves one grain at a time. Unlike mountains pushed up by colliding continents, volcanic peaks grow through countless individual eruptions, each adding another layer to their slopes. Some volcanic mountains are incredibly young in geological terms, built entirely within the last few thousand years. Others have been constructing themselves for millions of years, grain by grain, eruption by eruption. Each layer tells the story of a specific moment in time, preserving the chemical signature of ancient atmospheres and the rhythm of Earth's internal fires. Mountain meadows bloom in synchronized waves across entire ranges. High alpine meadows follow a precise choreography of flowering, triggered by snowmelt and temperature patterns that sweep across mountain ranges like slow waves. Wildflowers don't bloom randomly, but in careful sequence, each species waiting for its precise moment in the brief mountain summer. The result is a cascade of color that moves upslope as the season progresses, carpets of lupine giving way to paintbrush, then to delicate alpine forget-me-not that bloom at the very edge of the growing season. Underground rivers flow through the hearts of many mountain ranges. Deep within limestone mountains, water carves vast networks of caves and underground rivers that may never see daylight. These subterranean waterways can flow for hundreds of miles through mountain interiors, creating hidden ecosystems in perpetual darkness. Some of these underground rivers eventually emerge as large springs in valleys below, their crystal-clear water having traveled secret pathways through the mountain's heart. The water that bubbles up from these springs may have fallen as rain on distant peaks, years or even decades ago. Mountain peaks can be islands of ancient climate preserved in modern times. On some high peaks, plant and animal communities exist that are remnants of Ice Age conditions, isolated above the tree line while the world below warmed. These biological islands contain species that once lived at much lower elevations, but retreated upward as climates changed. They're living museums of ancient Earth. places where you can walk among plants and animals that knew a world of mammoths and saber-toothed cats, now clinging to existence in the thin air of high places. The gravitational pull of large mountains can actually be measured. Mountains are massive enough to exert their own gravitational influence, slightly deflecting plumb lines and affecting sensitive instruments. Early surveyors sometimes had to account for the gravitational attraction of nearby peaks when trying to establish accurate measurements. This mountain gravity is incredibly subtle but real, a reminder that these stone giants are heavy enough to bend space slightly around them, creating gentle wells in the fabric of reality itself. Avalanches move on cushions of compressed air. When snow breaks loose from steep mountain slopes, it doesn't just tumble down the mountainside. Large avalanches create their own cushion of compressed air that allows them to flow like liquid, reaching speeds of over 100 miles per hour. This air cushion allows avalanches to leap across valleys and flow uphill on the opposite side, defying gravity through the sheer force of their momentum. The sound of a major avalanche can be heard for miles, a deep rumble that seems to come from the mountain itself. Mountain lakes can be perfectly stratified into layers that never mix. In deep alpine lakes, water of different temperatures and densities can form distinct layers that remain separate for decades or even centuries. The deepest waters, near freezing and rich with dissolved minerals, may never reach the surface. These stratified lakes create unique habitats at different depths, each layer with its own chemistry and microscopic life. Some mountain lakes have bottom waters that haven't been exposed to air for thousands of years, preserving ancient atmospheric conditions in liquid form. Certain mountains sing when the wind is just right. Some mountain ranges contain rock formations that act like massive wind instruments, creating haunting musical tones when air flows through them at particular speeds and directions. These singing mountains have inspired legends and folklore in cultures around the world. The sound can range from low humming to high whistling, depending on the size and shape of the rock formations and the strength of the wind. These natural concerts happen unpredictably, turning mountains into occasional symphonies played by the atmosphere itself. Mountain permafrost can preserve organic matter for millions of years. High on some peaks, the ground remains permanently frozen, creating natural freezers that can preserve plant and animal remains with remarkable fidelity. Scientists have discovered perfectly preserved moss, insects, and even small mammals in mountain permafrost, some dating back hundreds of thousands of years. These frozen archives provide windows into ancient mountain ecosystems, showing what life was like on these peaks during different climatic periods. The air pressure at mountain peaks is so low that water boils at lukewarm temperatures. At the summit of Mount Everest, the air pressure is only about 1/3 of what it is at sea level. This means that water boils at roughly 160 degrees Fahrenheit, instead of the familiar 212 degrees. This lower boiling point affects everything from cooking to the behavior of liquids in the human body. The physics of everyday life change subtly at high altitudes, where the familiar rules of sea level no longer apply. Some mountain ranges are still growing from collisions that began millions of years ago. The Himalayas continue to rise because India is still pushing northward into Asia, a continental collision that began about 50 million years ago and shows no signs of stopping. This ongoing crash happens so slowly that mountains can continue growing for tens of millions of years after the initial impact. The collision zones where continents meet are places where Earth's surface crumples like slow-motion waves, creating mountain ranges that may continue rising long after human civilization has passed into history. Mountain glaciers contain libraries of ancient atmospheric conditions. Ice cores drilled from mountain glaciers reveal detailed records of past climates, preserving bubbles of ancient air and microscopic particles from volcanic eruptions, dust storms, and even forest fires from centuries past. Each annual layer of ice is like a page in Earth's diary, recording the chemical composition of the atmosphere, the temperature, and major events that affected the global climate. These frozen libraries allow scientists to read the story of Earth's climate going back thousands of years. Moonlight can trigger avalanches on certain mountain slopes. The gentle warming effect of moonlight on snow-covered slopes is sometimes just enough to destabilize snow layers that are already under stress. Mountain guides and avalanche experts know that full moon periods can bring increased avalanche activity, not because of any mystical influence, but simply because the additional radiant energy can be the final trigger that releases unstable snow. Even the pale light of the moon carries enough energy to tip the delicate balance between stability and movement on steep mountain faces. Mountains create their own lightning patterns during storms. The irregular terrain of mountain ranges affects how electrical charges build up during thunderstorms, often creating dramatic lightning displays that follow the contours of ridges and valleys. Mountain peaks act like natural lightning rods, attracting electrical discharges and creating spectacular shows of natural electricity. Some peaks are struck by lightning dozens of times each year, their rocky summits bearing the scars of countless electrical encounters with passing storms. High mountain environments can preserve sound waves in thin, cold air. In the rarefied atmosphere of high peaks, sound waves can travel much farther than they do at lower elevations. The cold, dense air and lack of obstacles allow voices and other sounds to carry with startling clarity across vast distances. Mountain climbers often report being able to hear conversations from camps that appear to be miles away, and the crack of ice or falling rocks can echo for minutes through the thin air. Some mountains contain entire ecosystems that exist nowhere else on Earth. Isolated peaks can act like biological islands, allowing unique species to evolve in complete isolation from their lowland relatives. These endemic species, found only on specific mountains or mountain ranges, represent millions of years of separate evolutionary development. From tiny insects adapted to life in perpetual cold, to plants that bloom only in the brief alpine summers, these mountain specialists remind us that evolution never stops experimenting, even in the harshest environments. The weight of mountains can actually depress the Earth's crust beneath them. Large mountain ranges are heavy enough to cause the underlying rock to sink deeper into the Earth's mantle, creating what geologists call isostatic depression. This sinking happens over millions of years and can amount to several miles of vertical displacement. When mountains eventually erode away, the underlying crust slowly rebounds upward, like a cushion returning to its original shape, after a heavy weight is removed. This process can continue for millions of years after the mountains themselves have worn away. Mountain winds can carry seeds and spores across continents. The powerful air currents that flow around and over mountain ranges can transport plant seeds, fungal spores, and even microscopic animals across vast distances. Some alpine plants found on widely separated mountain ranges are nearly identical because their seeds have been carried by high-altitude winds from peak to peak over thousands of years. Mountains act as stepping stones for life, allowing species to spread across continents by hopping from one high place to another on the currents of mountain-generated winds. Ancient mountain ranges can be traced by following chains of isolated peaks. Some mountain ranges that were once continuous have been broken apart by millions of years of erosion, leaving only scattered peaks as evidence of their former grandeur. Geologists can reconstruct these vanished ranges by studying the chemistry and age of rocks in widely separated mountains, discovering that peaks thousands of miles apart were once part of the same great mountain system. These geological detective stories reveal how continents have drifted and collided over Earth's long history, drifted and collided over Earth's long history. Mountain springs emerge from hidden journeys that began as raindrops years ago. Deep within mountain masses, water follows secret pathways through fractured rock and limestone chambers, traveling distances we can barely imagine through absolute darkness. Some of this water fell as precipitation on distant peaks decades earlier, slowly percolating through layers of stone, picking up minerals and trace elements that give each spring its unique character. When these underground travelers finally emerge into daylight, they create oases of life in otherwise harsh mountain environments. The water that bubbles from a mountain spring may have begun its journey before you were born, patiently working its way through the mountain's hidden circulatory system. Some mountains breathe with the seasons, expanding and contracting with temperature changes. The massive stone bodies of mountains are not as solid as they appear. During warm months, thermal expansion causes rock to grow slightly, while winter cold makes it contract. Over the course of a year, a large mountain peak might change its height by several inches, simply due to temperature variations. This geological breathing is imperceptible to human observation, but sensitive instruments can detect these seasonal fluctuations. The mountains around us are quietly alive with thermal motion, expanding toward summer skies and contracting under winter stars in an endless cycle of stone respiration. Certain mountain minerals glow softly under moonlight and starlight. High in some mountain ranges, deposits of fluorescent minerals absorb ultraviolet light during the day and release it slowly as a faint glow after dark. These phosphorescent rocks can make mountain slopes shimmer with an ethereal light on clear nights, visible only to those who know where to look. The glow is subtle, like captured starlight being slowly released back to the sky. Some mountain climbers report seeing entire cliff faces glowing faintly in the darkness, turning familiar daytime landscapes into something magical and otherworldly. Mountain forests create their own fog through the breath of trees. In certain mountain climates, dense forests generate their own weather patterns by releasing moisture through their leaves. This process, called evapotranspiration, can create localized fog banks that drift through mountain valleys like ghostly rivers. The trees literally breathe water vapor into the air, and on cool mornings, this moisture condenses into mist that flows downhill following the contours of the landscape. Some mountain forests are perpetually shrouded in these self-made clouds, creating mystical environments where visibility extends only a few feet in any direction. The highest peaks exist in a zone where the sky begins to fade toward black. At extreme altitudes, the atmosphere becomes so thin that the familiar blue of the sky starts to deepen toward the indigo and black of space. Mountain climbers at the highest elevations often describe looking up into sky that appears almost purple or dark blue, even during daylight hours. This happens because there are fewer air molecules to scatter sunlight, allowing more of the deeper cosmic background to show through. In these rarefied heights, climbers exist at the boundary between Earth's atmosphere and the infinite darkness beyond. Some mountain caves contain underground waterfalls that have never been seen by human eyes. Deep within limestone mountains, water creates spectacular subterranean features that rival any surface waterfall in beauty and grandeur. These hidden cascades can be hundreds of feet tall, tumbling through vast chambers carved by millions of years of flowing water. The sound of these underground waterfalls creates a constant whisper that resonates through mountain interiors. A secret music played in halls of stone that few will ever witness. Some of these hidden falls are larger and more magnificent than famous surface waterfalls, performing their liquid ballet in perfect darkness. Mountain flowers have evolved to bloom in slow motion to survive harsh conditions. Alpine wildflowers often take weeks or even months to complete bloom cycles that lowland plants finish in days. This deliberate pace allows them to conserve energy and make the most of brief growing seasons and harsh weather conditions. Some mountain flowers remain in bud for most of the summer, opening only during the warmest part of the day and closing again as temperatures drop. Their petals are often thicker and more durable than their valley cousins, designed to withstand sudden temperature changes and strong mountain winds. Certain mountains create their own aurora-like phenomena through electromagnetic effects. Some peaks contain large deposits of magnetic minerals that can interact with Earth's magnetic field and solar radiation to create faint light displays similar to the northern lights. These mountain auroras are much subtler than their polar counterparts, appearing as gentle glows or shimmers around rocky summits during periods of high solar activity. The phenomenon is rare and requires specific combinations of mineral content, atmospheric conditions, and solar particle bombardment, making sightings precious gifts for those fortunate enough to witness them. Mountain snow can remain completely pristine for decades in protected locations. In certain high-altitude cirques and north-facing bowls, snow can accumulate and remain undisturbed by wind or melting for extraordinary periods. Some of these protected snow deposits contain layers that are decades old, preserved like frozen pages in a book of mountain weather history. The deepest layers of these ancient snowfields may have fallen during your grandparents' youth, still pristine and untouched, waiting patiently for the right combination of temperature and sunlight to continue their journey toward the sea. Underground rivers beneath mountains can be warmed by geothermal heat from Earth's interior. Deep within some mountain ranges, water flowing through underground channels encounters heat from Earth's core, creating warm springs that emerge at surprising elevations. These geothermally heated waters can remain liquid even in sub-freezing surface conditions, creating oases of warmth that support unique ecosystems. Some high-altitude hot springs exist in locations where surface water would normally freeze solid, their heat rising from deep sources to create pockets of tropical warmth in otherwise Arctic environments. Mountain peaks can cast shadows that are visible from space. The tallest peaks create shadow patterns that extend for hundreds of miles across surrounding landscapes, shadows so large and distinct they can be seen in satellite photographs. During certain times of day and year, mountain shadows stretch across entire valleys and plains, creating geometric patterns of light and dark that shift slowly as the sun moves across the sky. These massive shadows affect local weather patterns and can create temperature differences that influence wind currents and precipitation far from the mountains themselves. Some mountain ranges contain natural stone bridges formed by millions of years of wind erosion. High winds channeled through mountain passes can carve spectacular arches and bridges from solid rock over geological timescales. These natural sculptures are shaped by the patient work of wind-carried particles, each grain of sand acting like a tiny chisel guided by mountain air currents. The resulting formations often span enormous gaps between peaks, creating bridges of stone that appear almost too delicate to support their own weight, yet have stood for millions of years. Mountain atmospheric pressure changes can affect the behavior of gases trapped in rocks. At high altitudes, the reduced air pressure allows gases that have been trapped in rock formations for millions of years to slowly seep out and escape into the atmosphere. This process, called degassing, happens so gradually it's nearly imperceptible. But over geological time, it can significantly alter the chemical composition of both the rocks and the surrounding air. Some mountain peaks are slowly releasing ancient atmospheric gases that were trapped when the rocks first formed, adding whispers of the distant past to the mountain air. Certain mountain minerals can naturally purify water as it flows through underground channels. Some mountain aquifers contain specific combinations of minerals that act as natural filtration systems, removing impurities and adding beneficial elements to groundwater as it moves through the rock. These natural water treatment systems can be more effective than human-engineered filtration, producing water of extraordinary purity that emerges from mountain springs. The minerals involved in this process often include zeolites and other naturally occurring compounds that can selectively remove harmful substances while leaving beneficial minerals intact. Mountain lightning can create natural glass in rock formations through intense heat. When lightning strikes certain types of rock on mountain peaks, the intense heat can actually melt and fuse minerals into natural glass formations called fulgurites. These lightning glasses preserve the exact shape and pattern of the electrical discharge that created them, forming twisted tubes and branching structures that mirror the path lightning took through the rock. Some mountain peaks contain entire collections of these natural glass sculptures, each one a frozen moment of electrical violence transformed into delicate art. High mountain environments can preserve ice that contains bubbles of atmosphere from thousands of years ago. In the permanent ice fields of the highest peaks, layers of frozen water trap samples of ancient air in tiny bubbles. These atmospheric time capsules allow scientists to study what Earth's air was like centuries or millennia ago, including levels of carbon dioxide, methane, and other gases. Some mountain ice contains air bubbles that were trapped before human civilization began, preserving samples of a pristine atmosphere that existed when the world was truly wild. Mountain ecosystems can exist in vertical layers so distinct they function like separate worlds. On tall peaks, different elevation zones create completely different habitats within just a few thousand feet of vertical distance. Desert plants might grow at the base, giving way to grasslands, then temperate forests, then boreal conifers, then alpine meadows, and finally bare rock and ice. Each zone has its own climate, seasons, and inhabitants, creating a compressed version of what you might experience traveling thousands of miles horizontally across different latitudes. Some mountains contain natural refrigerators in the form of permanently shaded crevices and caves. Deep clefts and caves on north-facing mountain slopes can remain below freezing year-round, even in temperate climates, creating natural cold storage areas that preserve organic matter for extraordinary periods. These mountain refrigerators have been used by various cultures throughout history to preserve food, and they sometimes contain remarkably well-preserved remains of ancient plants and animals that provide insights into past mountain ecosystems. Mountain magnetism can create areas where compasses spin wildly or point in completely wrong directions. Large deposits of magnetic minerals in some mountain ranges can overwhelm the weak signal from Earth's magnetic poles, creating zones where navigation instruments behave erratically. These magnetic anomalies have confused travelers for centuries and continue to affect modern GPS systems and electronic equipment. Some mountains have magnetic fields strong enough to pull metal objects like coins and keys right out of pockets, creating natural zones where the normal rules of magnetism no longer apply. Certain mountain streams flow uphill due to optical illusions created by the surrounding terrain. The complex topography of mountain landscapes can create visual tricks where water appears to flow against gravity. These illusions occur when the true slope of the land is masked by the dramatic angles and perspectives created by surrounding peaks and valleys. What looks like a stream flowing uphill is actually following the natural downward slope. But the visual context provided by towering mountains and steep valley walls creates a convincing illusion that defies logical expectation. Mountain air can carry sounds from incredible distances due to temperature inversions and atmospheric layers. Under certain atmospheric conditions, mountain valleys can act like giant speaking tubes, carrying whispered conversations for miles with startling clarity. Temperature inversions create layers in the atmosphere that can bend sound waves, causing voices and other noises to travel much farther than they normally would. Some mountain dwellers report being able to hear conversations from settlements that appear to be many miles away. The words carried on invisible atmospheric currents that flow between the peaks. The roots of mountains extend so deep, they can affect the flow of underground magma chambers, The massive foundations of mountain ranges can extend deep enough into Earth's crust to influence the movement of molten rock far below. These deep roots can redirect magma flows, affect the location of volcanic activity, and even influence the formation of new mountain ranges hundreds of miles away. The underground architecture of mountains is connected to Earth's deep internal processes in ways that can affect geological activity across entire continents. Some mountain peaks create their own gravitational time effects due to their mass and elevation. According to Einstein's theory of relativity, time moves slightly faster at higher elevations due to weaker gravitational fields. On the tallest mountain peaks, this effect is measurable with precise atomic clocks, though the difference amounts to only billionths of a second. This means that time literally moves faster on mountain summits than it does in valleys below, creating tiny time differentials across mountain landscapes. The peaks exist in a slightly accelerated time stream compared to their bases. Mountain weather patterns can be so localized that conditions can vary dramatically within just a few hundred yards. The complex topography of mountain terrain creates countless microclimates where weather conditions can change abruptly over very short distances. You might encounter blazing sunshine on one side of a ridge and freezing fog just over the crest. These micro-weather patterns are created by the interaction of elevation, slope orientation, wind patterns, and thermal effects, resulting in a patchwork of different conditions that can make mountain weather extremely difficult to predict. Ancient mountain building events can still be detected in the alignment of crystals within rocks. The immense pressures and stresses involved in mountain formation leave permanent records in the crystal structure of rocks, creating patterns that geologists can read like fossilized stress maps. These crystal alignments preserve the direction and magnitude of forces that acted on the rocks millions of years ago, allowing scientists to reconstruct the exact conditions that existed during ancient mountain-building events. The mountains carry within their very atoms the memory of the titanic forces that shaped them. Some mountain lakes freeze from the bottom up due to unusual mineral content and density gradients. In rare cases, mountain lakes with specific combinations of dissolved minerals and temperature layers can freeze in reverse, with ice forming first at the bottom and gradually working its way upward. This unusual freezing pattern occurs when dense, mineral-rich water at the lake bottom reaches freezing temperature, while lighter, warmer water floats above it. The result is an inverted ice formation that grows upward like an underwater crystal garden, creating unique winter landscapes hidden beneath the surface. Mountain erosion can create natural prisms that split sunlight into rainbow spectrums. Certain types of mountain minerals, when carved by erosion into specific shapes, can act as natural optical elements that break white light into its component colors. These geological prisms create rainbow effects in mountain environments, casting spectra of colored light across rock faces and valley floors during particular times of day. The rainbows appear and disappear as the sun moves across the sky, creating ephemeral light shows that transform familiar mountain landscapes into galleries of natural light art. High-altitude mountain environments can preserve sounds in ice formations that act like natural recordings. In some high mountain locations, sounds can become trapped in rapidly freezing ice formations, creating natural phonographs that preserve audio from the moment of freezing. While these ice recordings are extremely faint and require sensitive equipment to detect, they represent a form of natural sound preservation that occurs nowhere else on Earth. The ice holds onto vibrations from wind, falling rocks, animal calls, and other mountain sounds, creating frozen libraries of acoustic information from high-altitude environments. Mountain permafrost creates underground palaces of ice that can persist for millennia, deep within the hearts of high peaks. Permanently frozen ground forms intricate structures of ice and stone that remain stable for thousands of years. These frozen chambers exist in perfect darkness and silence, their ice formations growing slowly over centuries into elaborate crystalline sculptures. The permafrost acts as nature's deep freeze, preserving not just organic matter, but also creating unique geological formations where ice and rock merge into hybrid structures. Some of these underground ice palaces contain formations that rival the most spectacular surface caves, with frozen waterfalls, ice columns, and crystalline chambers that few human eyes will ever witness. The gravitational pull of mountain ranges can subtly influence the orbits of satellites passing overhead. Large mountain massifs exert enough gravitational force to create minor perturbations in the paths of spacecraft and satellites. These effects are incredibly small, but measurable with precise instruments, requiring occasional orbital corrections to maintain accurate satellite positioning. The gravitational signatures of major mountain ranges like the Himalayas and Andes create tiny anomalies in Earth's gravitational field that must be accounted for in space navigation. Even from hundreds of miles above, the silent presence of mountains makes itself known through invisible gravitational whispers. Some mountain forests communicate through underground fungal networks that connect individual trees across vast distances. Beneath the soil of mountain slopes, intricate webs of fungal threads called mycorrhizae link tree roots in vast underground internet systems. These fungal networks allow trees to share nutrients, water, and even chemical warning signals across entire mountainsides. A tree under attack by insects can alert distant neighbors through these subterranean connections, triggering defensive responses in trees that haven't yet been threatened. The mountain forest operates as a single interconnected organism, with individual trees acting as nodes in a vast living network. Mountain thermal springs can maintain constant temperatures year-round, regardless of surface weather conditions. Deep underground, geothermal heat keeps certain mountain springs at steady temperatures that never vary by more than a degree or two, even when surface conditions swing from blazing summer heat to bitter winter cold. These thermal oases create unique microenvironments where tropical plants can survive at high altitudes and specialized organisms thrive in conditions that remain constant, while the world above experiences dramatic seasonal changes. The springs act like windows into Earth's stable interior temperatures, offering glimpses of the planet's deep thermal equilibrium. Certain mountain peaks generate their own electrical fields through the movement of charged particles in thin atmosphere. At extreme altitudes, the interaction between cosmic radiation, thin air, and mineral content in rocks can create weak but measurable electrical fields around mountain summits. These natural electrical phenomena can affect sensitive equipment and sometimes create subtle aurora-like glows around rocky peaks during periods of high atmospheric activity. The mountains become natural electrical generators, drawing energy from cosmic sources and the movement of charged particles through their rarefied atmospheric environments. Mountain glaciers can preserve microscopic life forms in suspended animation for hundreds of thousands of years. Deep within glacial ice, bacteria, algae, and other microorganisms can remain dormant but viable for extraordinary periods, essentially frozen in time until changing conditions allow them to revive. When these ancient ice layers melt, they can release living organisms that have been waiting patiently for millennia to resume their life cycles. Some of these revived microbes represent evolutionary snapshots from vastly different climatic periods, offering insights into how life adapts to changing environmental conditions over geological timescales. The acoustic properties of mountain valleys can create natural amphitheaters with perfect sound reproduction. Some mountain valleys have shapes and rock compositions that create ideal acoustic conditions, amplifying and clarifying sounds with remarkable fidelity. These natural concert halls can make a whispered conversation audible across distances of several miles while maintaining perfect clarity and tonal quality. The precise angles of valley walls, combined with specific atmospheric conditions, create acoustic focusing effects that concentrate and direct sound waves with the precision of engineered audio equipment. Mountain building processes can create natural time markers by aligning magnetic minerals with ancient magnetic field orientations. As mountains form, iron-bearing minerals in the rocks align themselves with Earth's magnetic field at the time of formation, since Earth's magnetic field periodically reverses its polarity. These mineral alignments create permanent records of when different parts of mountains were formed. Geologists can read these magnetic signatures like dates stamped in stone, reconstructing not only when mountains were built, but also tracking the wandering of magnetic poles over millions of years. Some mountain environments contain natural laboratories where unique chemical reactions occur nowhere else on Earth. The combination of extreme temperature variations, intense ultraviolet radiation, and specific mineral compositions found at high altitudes can trigger chemical processes that don't happen at lower elevations. These mountain chemistry sets produce unusual compounds and mineral formations that require the precise conditions found only in high-altitude environments. Some of these reactions proceed so slowly they take centuries to complete, creating chemical processes that span multiple human generations. Mountain atmospheric conditions can create natural lenses that magnify and focus starlight into concentrated beams. The combination of thin, stable air and specific humidity conditions at high altitudes can create atmospheric lensing effects that concentrate starlight and make distant celestial objects appear brighter and more focused than they do at sea level. These natural telescopic effects occur most commonly during certain weather patterns and can make stars appear to pulse or flicker with unusual intensity. Some mountain peaks offer viewing conditions that rival those of major astronomical observatories. Deep mountain caves can contain atmospheres with completely different chemical compositions than surface air. In sealed cave systems within mountains, gases can accumulate and concentrate over thousands of years, creating underground atmospheres that may contain higher concentrations of carbon dioxide, methane, or other gases than normal air. Some of these cave atmospheres preserve samples of ancient air compositions, while others develop unique chemical balances through interactions with surrounding rock formations. These hidden atmospheric pockets create environments where life must adapt to fundamentally different breathing conditions. Mountain snow can accumulate in patterns that create natural insulation systems, protecting underlying ecosystems. In certain mountain environments, wind patterns and terrain features cause snow to accumulate in specific configurations that act like engineered insulation systems. These natural snow architectures can maintain stable temperatures beneath their layers, creating protected microclimates where plants and small animals can survive harsh winter conditions. The snow formations act like igloos or insulated shelters, demonstrating principles of thermal engineering that humans have only recently discovered. Some mountain minerals exhibit piezoelectric properties, generating small electrical charges when subjected to pressure changes. Quartz and other crystals found in mountain environments can produce measurable electrical voltages when squeezed or subjected to stress from thermal expansion, seismic activity, or atmospheric pressure changes. These natural electrical generators create tiny but persistent electrical fields within mountain environments, contributing to the overall electromagnetic signature of high-altitude locations. The mountains literally generate their own power through the constant stresses and pressures acting on their crystalline components. Mountain atmospheric pressure changes can cause certain rocks to emit faint sounds as trapped gases escape. As barometric pressure fluctuates with weather patterns, some mountain rock formations release tiny amounts of trapped gas through microscopic fissures, creating subtle whistling or sighing sounds that are barely audible to human ears. These geological exhalations follow atmospheric pressure cycles, with rocks literally breathing in response to weather changes. The sounds are most noticeable during rapid pressure changes associated with approaching storms or significant weather fronts. High mountain environments can preserve pollen and spores in ice formations that provide detailed records of ancient plant communities. Layers of mountain ice contain microscopic samples of pollen from plants that lived thousands of years ago, creating detailed archives of how mountain plant communities have changed over time. These frozen botanical libraries preserve evidence of species that may have vanished from modern mountain environments, offering insights into how plant communities respond to long-term climate variations. Each ice layer represents a snapshot of the mountain's botanical heritage from a specific moment in the distant past. Certain mountain locations experience gravitational anomalies where objects appear to behave unusually due to local mass concentrations. Dense mineral deposits or unusual underground rock formations can create localized gravitational effects that make objects roll uphill, cause pendulums to swing in unexpected directions, or create other apparent violations of normal gravitational behavior. These gravitational quirks result from the uneven distribution of mass within mountain structures, creating pockets where the local gravitational field differs noticeably from the regional norm. Mountain valleys can act as natural wind tunnels that accelerate air currents to remarkable speeds. The funnel-like shape of certain mountain valleys can compress and accelerate wind flow, creating natural wind tunnels where air velocities can reach hurricane-force speeds even when surrounding areas experience only gentle breezes. These wind acceleration effects can create dangerous conditions for aircraft and generate powerful downdrafts that extend for miles beyond the mountain valleys themselves. The concentrated wind energy can also carve distinctive erosion patterns and transport material across vast distances. Some mountain peaks contain natural sundials formed by rock formations that cast precise shadows throughout the day. Erosion and geological processes have created rock formations on certain peaks that function as accurate timepieces, casting shadows that move predictably across marked surfaces as the sun travels across the sky. These natural chronometers were sometimes recognized and used by ancient peoples for timekeeping, representing some of the earliest astronomical instruments created entirely by geological processes rather than human engineering. Mountain ecosystems can create their own soil from nothing but rock and time through patient biological processes. On newly exposed rock surfaces high on mountain slopes, pioneering organisms like lichens and mosses begin the slow process of soil creation by breaking down stone and accumulating organic matter grain by grain. Over centuries, these biological soil engineers transform bare rock into fertile growing medium that can support increasingly complex plant communities. The process demonstrates how life can literally create the foundations for its own expansion into seemingly impossible environments. Certain mountain formations can focus and amplify seismic vibrations, making earthquake waves stronger in specific locations. The shape and composition of some mountain structures can act like geological amplifiers, concentrating seismic energy and making earthquake vibrations more intense in particular areas. These seismic focusing effects can cause earthquake damage patterns that seem inconsistent with distance from the epicenter, with some mountain locations experiencing stronger shaking than areas that are technically closer to the source of seismic activity. Mountain atmospheric conditions can preserve scent molecules for extended periods, creating natural archives of aromatic information. The cold, dry air and low atmospheric pressure found at high altitudes can slow the breakdown of volatile organic compounds, allowing scents to persist much longer than they would at lower elevations. Some mountain environments can hold on to aromatic traces of seasonal flowers, forest fires, or other scent sources for weeks or months after the original source has disappeared, creating atmospheric libraries of olfactory information. High mountain lakes can develop unique optical properties that make them appear different colors depending on viewing angle and lighting conditions. The combination of dissolved minerals, microscopic organisms, and the optical effects of deep, pure water can cause some mountain lakes to display unusual colors or color-changing properties. These lakes might appear deep blue from one angle and emerald green from another, or shift colors dramatically as lighting conditions change throughout the day. The optical effects result from complex interactions between light, water chemistry, and suspended particles that create natural color displays. Some mountain environments contain natural refrigeration systems that use evaporation and thermal gradients to maintain below freezing temperatures. In certain mountain microclimates, the combination of wind patterns, evaporation effects, and thermal radiation can create cooling systems that maintain freezing temperatures even when surrounding areas are above freezing. These natural refrigeration zones often occur in shadowed areas with specific combinations of airflow and moisture conditions, demonstrating principles of thermodynamics that operate without any mechanical assistance. Mountain building processes can create natural stress relief systems that prevent catastrophic geological failures through gradual energy release. The immense pressures involved in mountain formation are often relieved through networks of small fractures and micro-movements that distribute stress gradually, rather than allowing it to build up to dangerous levels. These natural safety systems prevent catastrophic landslides and geological collapses by providing pathways for gradual stress release. The mountains essentially manage their own structural integrity through built-in pressure relief mechanisms. Certain mountain atmospheric conditions can create standing wave patterns in clouds that remain stationary for hours despite strong winds. When air flows over mountain ridges at specific speeds and angles, it can create stationary wave patterns in cloud formations that appear to hover motionlessly above peaks, even though the air itself is moving rapidly. These standing cloud waves can maintain their shape and position for extended periods, creating the illusion of clouds that are somehow anchored to the mountains below them, despite being composed of constantly moving air and water vapor. High-altitude mountain environments can cause normally stable materials to behave in unusual ways due to temperature extremes and pressure changes. Metals can become brittle, plastics can shatter like glass, and rubber can lose all flexibility in the extreme conditions found on high mountain peaks. These material property changes occur because the molecular behavior of substances shifts dramatically under the combined stresses of low temperature, low pressure, and intense ultraviolet radiation. Materials that are perfectly reliable at sea level can fail unexpectedly in mountain environments. Some mountain regions contain natural particle accelerators, where cosmic rays interact with atmospheric particles to create subatomic particle showers. High mountain peaks extend into the upper atmosphere, where cosmic ray interactions are more frequent and intense than at lower elevations. These cosmic particle collisions can create cascades of secondary particles that rain down through mountain atmospheres, creating natural laboratories for high-energy physics research. The mountains provide platforms for studying cosmic ray interactions that would be difficult to observe at lower altitudes. Mountain thermal effects can create natural convection currents that transport seeds, spores, and small organisms across vast distances. The heating and cooling cycles created by mountain topography generate predictable air currents that can carry biological material hundreds of miles from its origin. These thermal transport systems help explain how similar species can be found on widely separated mountain peaks, having been carried by natural convection currents that follow mountain-generated wind patterns. The mountains act as biological distribution networks, spreading life across landscapes through their thermal dynamics. And as these gentle truths about mountains settle into your awareness like evening mist gathering in quiet valleys, Let your breathing slow to match the patient rhythm of geological time. We've wandered together through peaks that sing with wind, valleys that preserve ancient air, and stones that hold the memory of vanished seas. Each fact has been a stepping stone on a path that leads not to any destination, but simply to rest. The mountains around us continue their slow work of growing and weathering, of catching snow and releasing streams, of standing as silent witnesses to time itself. They ask nothing of us but wonder, and they offer everything in return: peace, perspective, and the quiet knowledge that some things endure not through struggle, but through patient acceptance of whatever comes. In the deepest mountain valleys, ancient trees grow rings that record conversations between earth and sky. These silent chroniclers, some over 1,000 years old, carry within their wooden hearts the story of every drought, every abundant rain, every harsh winter and gentle spring they have witnessed. Each ring is a year made solid, a calendar written in cellulose and time. The width of each band tells of the mountain's mood during that particular year. Narrow rings speaking of hardship, wide ones of plenty. Scientists can read these wooden libraries like books, discovering years when volcanic eruptions dimmed the sun, when earthquakes shook the roots, when perfect seasons allowed trees to grow with unusual vigor. In the quiet circles of mountain timber lies a record more faithful than any human memory. Some mountain caves contain their own weather systems, complete with clouds and precipitation. Deep within limestone caverns, temperature differences and humidity levels can create miniature weather patterns that mirror those on the surface. Warm, moist air rising from underground streams meets cooler air from deeper passages, creating cloud formations that drift through vast chambers like ghosts in a stone sky. These subterranean clouds sometimes produce their own gentle rain, creating underground precipitation that has never felt sunlight. The caves breathe with their own rhythms, generating fog that flows through passages like slow rivers of mist, creating weather patterns that exist in perpetual twilight. Mountain flowers have developed their own language of color that changes with elevation. As you climb higher, alpine blooms shift their palette in response to increasing ultraviolet radiation and changing atmospheric conditions. Flowers that appear pale pink at lower elevations may bloom in deep magenta at altitude, their pigments intensifying to protect delicate tissues from harsh mountain light. Some species produce completely different colors at different elevations, creating graduated rainbows of the same flower species that paint mountainsides in vertical bands of shifting hue. This chromatic adaptation allows plants to fine-tune their solar protection while maintaining their ability to attract the few hardy pollinators that venture into high places. Certain mountain stones sing with voices that change with the weather. Limestone formations in some mountain ranges contain hollow chambers and passages that act as natural organ pipes, producing musical tones when wind passes through them at specific angles and velocities. The pitch and timbre of these stone songs vary with humidity, temperature, and atmospheric pressure, creating mountain symphonies that shift with changing weather patterns. Some peaks have acquired local legends about spirits or voices in the stone, but the reality is more beautiful than any myth. The mountains themselves become musical instruments played by the atmosphere, their songs audible only to those patient enough to listen during the right conditions. Underground mountain rivers can flow in complete silence through chambers so large they could contain entire cities. These hidden waterways carve vast spaces within mountain hearts, creating cathedral-like chambers where water flows without sound across perfectly smooth stone floors. The absence of turbulence in these deep channels eliminates the familiar gurgle and splash of surface streams, replacing it with a silence so complete it seems to have weight. Some of these subterranean rivers are hundreds of feet wide and flow for dozens of miles through absolute darkness. Their waters as clear as crystal and as silent as thought itself. High mountain peaks can experience temperature swings of over 100 degrees in a single day. The thin atmosphere at altitude provides little insulation against the extreme temperature variations between day and night, creating thermal environments that swing from blazing heat in direct sunlight to bitter cold in shadow. These dramatic temperature fluctuations happen gradually enough that mountain-adapted plants and animals can adjust, but they create unique challenges that have shaped the evolution of high-altitude life. Some mountain creatures have developed the ability to enter temporary dormancy during the coldest parts of each daily cycle, essentially hibernating for a few hours each night. Mountain atmospheric pressure changes can cause some rocks to change color as minerals respond to stress variations. Certain crystalline formations contain pressure-sensitive minerals that shift their optical properties as atmospheric conditions change. These chromatic rocks act like natural barometers, their colors shifting subtly with approaching weather systems or seasonal pressure changes. The color changes are usually subtle, visible only to trained observers, but they represent a form of geological weather prediction that operates on time scales from hours to seasons. Some mountain climbers have learned to read these color shifts as indicators of approaching storms or pressure changes. Some mountain valleys contain natural echo chambers, where sounds can reverberate for several minutes. The precise acoustic properties of certain valley configurations can create echo effects that far exceed anything possible in human-built structures. A single shout in these valleys can return as a series of overlapping echoes that gradually fade over periods of several minutes, each repetition slightly different in tone and clarity as the sound bounces off different rock surfaces. These natural echo chambers often have spiritual significance for local cultures, places where the boundary between speaking and listening becomes beautifully blurred. Mountain permafrost can preserve the molecular structure of organic compounds for millions of years. In the permanently frozen ground of high peaks, complex organic molecules can remain chemically intact for periods that dwarf human timescales. These molecular time capsules preserve not just the physical remains of ancient life, but also the chemical signatures of past atmospheric conditions, ancient soil compositions, and even traces of cosmic events that affected Earth's upper atmosphere. Scientists studying mountain permafrost have discovered organic compounds that provide direct chemical evidence of environmental conditions from epochs when the planet was fundamentally different. Certain mountain formations act as natural seismographs, amplifying and recording earthquake vibrations in their crystal structures. Some mountains contain mineral formations that respond to seismic activity by developing microscopic stress patterns that remain permanently recorded in crystal lattices. These geological seismographs can preserve evidence of earthquake activity for millions of years, allowing scientists to study the seismic history of regions long before human observation began. The mountains become libraries of geological violence, their crystal structures holding memories of every significant tremor that has passed through the bedrock. High mountain snow can develop its own internal weather systems, as temperature gradients create circulation patterns within deep snowpacks. Thick accumulations of mountain snow often develop complex internal structures with temperature differences between layers that drive air circulation through the snowpack. These internal weather systems can create ice formations, air pockets, and circulation patterns that exist entirely within the snow itself. The snowpack breathes with its own rhythm, drawing in surface air and exhaling through hidden vents, creating a hidden atmospheric system that exists in the boundary between solid and gas. Some mountain lakes are so deep and clear, they create optical illusions that make the bottom appear to be just a few feet below the surface. The combination of exceptionally pure water and specific lighting conditions can eliminate visual depth cues, making lake bottoms that are hundreds of feet deep appear close enough to touch. These optical lakes have been the source of countless accidents and legends, as their deceptive clarity lures observers into believing they could easily wade across what are actually profound depths. The illusion results from the absence of suspended particles and the specific refractive properties of mountain lake water. Mountain atmospheric conditions can create natural holographic effects where distant objects appear as three-dimensional projections floating in space. Temperature inversions and humidity gradients in mountain air can act like natural holographic systems, creating detailed three-dimensional images of distant landscapes that appear to float above the actual terrain. These atmospheric holograms can be remarkably detailed and stable, sometimes persisting for hours before atmospheric conditions change enough to dispel them. The effect is most common during specific weather patterns and can make distant mountain ranges appear to hover above the horizon like aerial mirages. Certain mountain minerals can store and slowly release absorbed sound energy over periods of days or weeks. Some crystalline formations have acoustic properties that allow them to absorb sound waves and release them gradually over extended periods, creating a form of natural sound storage. These acoustic reservoirs can capture the sounds of storms, avalanches, or other mountain events, and replay them as faint echoes days or weeks later. The effect is subtle and requires quiet conditions to detect, but it means that mountain environments can hold on to acoustic memories long after the original sounds have faded. Deep mountain caves can maintain perfect acoustic isolation, creating spaces where sound behaves in ways impossible on the surface. Some underground chambers are so effectively isolated from external noise and have such specific acoustic properties that they create perfect sound environments where even the smallest whisper can be heard with startling clarity. These natural anechoic chambers eliminate all echo and reverberation, creating acoustic conditions that can be disorienting to visitors accustomed to the complex sound environments of the surface world. Mountain building processes can create natural gyroscopes in the form of spinning mineral formations that maintain their orientation for millions of years. During mountain formation, certain mineral crystals can become locked into rotating configurations that preserve their angular momentum over geological timescales. These natural gyroscopes continue spinning at imperceptibly slow rates, maintaining their orientation relative to Earth's rotation axis, even as the mountains around them shift and change. The effect demonstrates how the immense forces involved in mountain building can create mechanical systems that operate on timescales far beyond human experience. Some mountain peaks generate their own magnetic north that differs from Earth's magnetic pole by measurable amounts. Large concentrations of magnetic minerals in certain mountains can create localized magnetic fields strong enough to override Earth's magnetic field in their immediate vicinity. These magnetic anomalies can cause compass needles to point toward the mountain peak rather than magnetic north, creating navigation challenges that have puzzled travelers for centuries. The magnetic mountains act like terrestrial magnets, each with its own magnetic pole that can influence navigation equipment for miles around. High-altitude mountain environments can create conditions where ice forms in geometric patterns that resemble natural crystals or mathematical structures. The combination of specific temperature, humidity, and wind conditions at extreme altitudes can cause ice to form in highly ordered geometric patterns that look almost artificially constructed. These ice formations often display perfect symmetry and mathematical precision, creating natural sculptures that appear too organized to be random products of weather and physics. The formations demonstrate how simple physical processes can create complex patterns when operating under the precise conditions found only at high altitudes. Mountain atmospheric conditions can create natural particle beams where dust, pollen, and other airborne materials become organized into coherent streams. Specific combinations of wind patterns, temperature gradients, and topographical features can cause airborne particles to organize themselves into visible beams that travel for miles through mountain air. These particle streams can transport biological materials, minerals, and other substances across vast distances with remarkable precision, creating natural transportation systems that operate entirely through atmospheric dynamics. Some mountain valleys act as natural time delay systems, where sounds from different elevations arrive at the valley floor at precisely timed intervals. The complex acoustic geometry of certain mountain valleys can cause sounds originating at different elevations to reach listeners at the valley floor in perfect temporal sequence, creating natural orchestration effects. A symphony of sounds from various mountain elevations can be heard as a perfectly timed acoustic composition, with each altitude contributing its voice at precisely the right moment to create harmonious combinations. Mountain snow can develop internal optical properties that create light transmission effects similar to fiber optic cables. Under specific conditions, consolidated snow can develop internal structures that allow light to travel through the snowpack along curved paths, similar to how light travels through optical fibers. These snow optics can transmit light from the surface to buried layers or transport light horizontally through snowbanks, creating illumination effects in unexpected locations. The phenomenon can make buried objects appear to glow from within the snow or create mysterious light sources that seem to have no obvious origin. Certain mountain formations contain natural laboratories where mineral synthesis occurs under conditions impossible to replicate artificially. The unique combinations of pressure, temperature, and chemical conditions found deep within mountain structures can trigger mineral formation processes that create compounds and crystal structures that cannot be produced in human laboratories. These natural synthesis chambers operate over geological timescales, slowly producing exotic minerals and crystal formations that represent the ultimate expression of geological chemistry. The mountains become nature's research laboratories, conducting experiments in materials science that span millions of years. High mountain environments can create conditions where the normal phases of matter behave in unusual ways, with substances existing simultaneously as solids, liquids, and gases. At the extreme conditions found on the highest peaks, the triple point, where all three phases of matter can coexist, becomes accessible for certain substances under natural conditions. Water, carbon dioxide, and other compounds can exist simultaneously in all three phases, creating unique physical environments where the familiar boundaries between solid, liquid, and gas become blurred. Some mountain atmospheric conditions can create natural laser effects, where light becomes coherent and concentrated through atmospheric lensing. Specific combinations of atmospheric conditions, ice crystals, and mineral particles in mountain air can occasionally create conditions that concentrate and organize light waves in ways similar to artificial laser systems. These natural lasers produce coherent light beams that can travel for considerable distances through mountain atmospheres, creating bright, focused light displays that appear without any obvious source. Mountain thermal dynamics can create natural refrigeration cycles that maintain constant temperatures in specific microclimates, regardless of seasonal variations. Some mountain locations experience thermal cycling effects that create natural climate control, maintaining stable temperatures throughout the year despite dramatic seasonal changes in the surrounding environment. These thermal oases result from complex interactions between ground temperature, air circulation, and radiative cooling effects that create closed-loop climate systems operating entirely through natural processes. Deep within mountain structures, pressure and temperature conditions can create natural diamond synthesis chambers where carbon transforms into crystalline forms over geological time. The immense pressures found deep within mountain roots, combined with specific temperature and chemical conditions, can trigger diamond formation processes that operate over millions of years. These natural diamond factories produce crystals of exceptional purity and size, hidden deep within mountain cores where they remain undiscovered unless geological processes eventually bring them closer to the surface. Mountain magnetic fields can create natural levitation effects, where certain metallic objects appear to float or move without apparent cause. In areas of intense magnetic fields around mountain peaks, ferromagnetic materials can experience forces strong enough to overcome gravity, creating natural levitation phenomena. These magnetic levitation effects can cause compasses, metal tools, and other iron-bearing objects to behave in seemingly impossible ways, floating in mid-air or moving along invisible magnetic field lines. Some mountain caves contain natural wind instruments, where air currents create complex musical compositions that change with atmospheric conditions. Cave systems with multiple chambers and connecting passages can act like enormous musical instruments, with air currents flowing through different openings to create harmonic combinations and melodic patterns. These cave orchestras can produce music that ranges from simple whistling to complex harmonies, with the compositions changing as atmospheric pressure and wind patterns shift. High mountain environments can preserve electromagnetic phenomena in mineral structures, creating natural recordings of cosmic events and atmospheric electrical activity. Certain mountain minerals can capture and store electromagnetic signatures from lightning strikes, aurora activity, and even cosmic ray interactions, preserving these electrical events in their crystal structures like natural electromagnetic recordings. These mineral memories can be read with sensitive instruments, revealing the electromagnetic history of mountain environments over thousands of years. Mountain atmospheric conditions can create natural holographic storage systems where three-dimensional images are preserved in ice crystal formations. Under specific conditions, ice crystals can form complex internal structures that preserve detailed three-dimensional optical information, creating natural holographic storage media that can retain visual information for extended periods. These ice holograms can preserve images of atmospheric phenomena, landscape features, and other visual information in crystalline form. Some mountain peaks create natural broadcasting systems where radio waves and other electromagnetic signals are amplified and retransmitted across vast distances. The geometric shape and mineral content of certain mountain peaks can create conditions that naturally amplify and focus electromagnetic radiation, turning mountains into natural radio transmitters that can relay signals far beyond their normal range. These natural broadcasting systems can affect radio communications, cellular signals, and other forms of electromagnetic communication in ways that are still not fully understood. And in the gentle quiet that follows these mountain mysteries, let your mind settle like snow on a windless peak. We have climbed through realms where stone sings and ice preserves ancient whispers, where the very air holds secrets and the depths conceal wonders that few will ever witness. Each truth has been a waypoint on this peaceful ascent. Each discovery a rest stop where wonder and knowledge meet in the thin air of understanding. The mountains continue their patient work around us, growing and weathering, storing and releasing, holding memories in crystal and stone while breathing slowly with the rhythms of deep time. They ask nothing but offer everything: strength without struggle, persistence without haste, and the quiet wisdom that comes from standing still while the world turns beneath star-filled skies. Now, as these mountain truths settle into your consciousness like morning dew on alpine meadows, let your breath find its own quiet rhythm. Your body can rest now, muscles releasing their hold on the day's tensions, thoughts growing soft around the edges like clouds drifting past distant peaks. The mountains we've explored together continue their ancient work in darkness and in light. They gather snow on their shoulders and release it as rivers to the valleys below. They stand as patient witnesses to time itself, changing so slowly that their transformations become poetry, written in stone across millions of years. In their presence, urgency fades. In their silence, peace takes root. Tonight, as sleep approaches like twilight settling over high country, you carry with you the memory of peaks that touch the sky and valleys that cradle ancient dreams. The mountains have shared their secrets with you, whispered their stories of time and weather, of ice and stone, of the slow dance between earth and heaven that has been unfolding since the world was young. Let their steadiness be your steadiness now. Let their patience teach you patience. In the high places of the world, where the air grows thin and the sky grows deep, there's a kind of peace that asks nothing and gives everything. A stillness that holds all movement, a silence that contains all sound. Rest now in that mountain peace. Let your dreams be as gentle as snowfall on sleeping peaks, as quiet as starlight on stone. The mountains will keep their watch through the night, standing guard over valleys where streams flow softly toward the sea, where ancient trees count years in rings of wood and memory. If you find yourself still awake, still listening, you might imagine yourself high on a quiet ridge where the air is clear and the view extends to horizons you've never seen. There, in the thin atmosphere where earth meets sky, breathe slowly and let yourself simply be. The mountains have been there for millions of years before you, and they will remain long after your own brief passage through this world. But right now, in this moment, you are part of their story, a warm breath of consciousness in the cold clarity of high places. And if these peaceful explorations have helped you find rest, if the gentle facts about stone and ice and sky have carried you towards sleep, then the mountains have done their work. They have offered you what they offer all who approach with quiet hearts. Not answers, but presence. Not solutions, but peace. The peaks around us continue their slow conversation with clouds and wind. Snow falls and melts and falls again. Rivers are born in high cirques and flow toward distant oceans. And somewhere in the patient rhythm of it all, in the breathing of glaciers and the whisper of wind through stone, there is a lullaby older than human memory, a song that has been singing since the first mountains rose from primordial seas. Listen now to that ancient music. Let it carry you gently toward rest. The mountains know the secret of time, how it moves like water, how it wears away the hardest stone, how it transforms everything while leaving the essential unchanged. In their presence, even sleep becomes a kind of prayer, a quiet offering to the mystery of being awake in a world so full of wonder. Now, as these mountain truths settle into your consciousness like morning dew on alpine meadows, let your breath find its own quiet rhythm. Your body can rest now, muscles releasing their hold on the day's tensions, thoughts growing soft around the edges like clouds drifting past distant peaks. The mountains we've explored together continue their ancient work in darkness and in light. They gather snow on their shoulders and release it as rivers to the valleys below. They stand as patient witnesses to time itself, changing so slowly that their transformations become poetry, written in stone across millions of years. In their presence, urgency fades. In their silence, peace takes root. Thank you for climbing with me tonight through these peaceful heights of knowledge and dream. May your rest be as deep as mountain valleys, as refreshing as snow-fed streams, as enduring as the slow patience of peaks reaching always toward infinite sky. If you happen to still be awake, you can go ahead and watch the next chapter now. And if you'd like to drift off to more gentle explorations like this, softly told and filled with wonder, consider subscribing. There are always more peaceful mysteries to discover, one sleepy soul at a time. Good night, fellow traveler. Good night.